Gosh, dang it, where did it go? There it is. This. So 3.1 on graphing. Of course, you know that there are different types of graphs, right? There's bar graphs and there's pie graphs and those type of graphs. They just pretty much graph what we call one variable data. Right? This type of graphing, we're talking about two variable data. So when you have, if you have graph paper, by the way, it would be probably pretty good to have some or be able to access it somehow. There are some free online graph papers you can download if you need to do that. But basically on a graph, this is a XY coordinate system here. All right, this is the x-axis here, and this is the y-axis here, and this is the origin right there. Okay, all right, which is the point 0, 0. And also quadrants, there's also quadrants, so this would be the first quadrant, which uses Roman numerals, very, very rare these days. Okay, so those are your quadrants, they're called. They might mention which quadrant, they might mention that somewhere in your book about which quadrant things are, but probably not so much. All right, so this is basically just the XY coordinate system right there. Okay, 1, 2, 3 positive, 1, 2, 3 negative, positive, negative, positive, negative. So it looks like that. Okay. Again, if you have some graph paper, it's a good thing, you know, to have in this unit particularly, but we can get away without it tonight for sure. So what we're going to do is we're just going to graph some points here real quick, and then we're going to collect some information. So I'm just going to graph some points, and most of you have probably graphed points before. A lot of people don't particularly like to graph, not exactly sure why. I'm just going to graph some points here. Okay, so I just kind of picked some numbers here to graph. So A is 3, 4. So we always start here at the 0, 0. So I'm going to go over 3 because this is the x coordinate and this is the y. Just like the alphabet, x comes before y. So I'm going to go over 3, up 4. Put that point right there. That's my A point. 3, 4. Just like that. B point would be back 2, up 5. So that's going to be right there. Okay, back 2, up 5, x, y. C point would be negative 2, back 2, down 3. That's going to be right there. And the D would be 4 and negative 5. Right there. Okay, so those are the points. Over, up or down, back and forth, depends upon the positive, negative, x, y. Okay. That's how you graph. That's how you locate points. So one of the assignment questions is going to ask you to graph some points, and I think it's going to ask you to say what point this. They're going to put some points on there and say write the coordinates. So then you would just say what the coordinates of it is. Make sure you locate it by going x, y first. If you have to do a fraction or a decimal point, then you just estimate where it is. Okay, I'm not going to go out and try to figure out whether this is you're exactly at a half. So if you had to do E, say 2.5 and 3 1/4. Okay, so 2.5 would be right about there. 3 1/4 would be right about there. So again, I'm not going to look and make sure, oh, they're a little bit off there, because it's just a sketch and we don't need that kind of accuracy when we're just kind of plotting some points regularly. Okay, so there's our graph. What we're going to do now is we're going to collect some information and we're going to make what we're calling a scatter plot. But for now we need to collect our height and shoe length. Okay. Normally I do this in centimeters because I like it better. That's a little more accurate. So what we'll do is we're still going to do it in centimeters, but all my centimeter rulers or yardsticks are gone. I don't know where they went. So we're going to do it in inches, and I'm going to convert it for you. So all we need to do is grab one of these guys here, measure your height, okay, this way, and shoe length that way. Once you get it, we're going to record it here. I don't need your names, I just need the numbers.
How many people?
How many do we have today?
Good answer.
I don't know.
Enough.
Yeah.
We're getting our foot size and height. No. I'm 6'4".
You're going to ask me centimeters. Here we go.
No shit. It's in centimeters, correct?
It's inches because I don't have centimeters, so I'm going to convert it for you. Take that one.
66 inches. But let's measure. Wait, no, I'm doing it. Can I just do 5
Like. So what we're going to do is normally when you have information, you take the first column, which is your X. Okay, so that's always usually the first column. So that's going to be down here, which would be our foot length. Okay, and then the Y would be the second column, which is our height. Okay, so then we'd have to go through and find, well, what would be a window we want to use. So I'm looking for the smallest here. Let's see, 22, I think I saw one. So we'd probably start maybe at a 20. Okay, largest would be maybe, I see a 30. So yeah, we maybe go 32. Okay, something like that. And then, we just need to have some nice divisions in between there. So that's about 12. So I could either go by ones, I could go by twos. You can set it up however you want to go by. All right, so let's say I decide to go by, let's see if I can get 12 of them in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh yeah, easily I can do that. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there. Okay, so there's that one. Okay, and then the height. Okay, I've got anything from about 150 to about 180. So I'll put 150 maybe. I probably don't want to put 150 down there. I want to have a little bit of room. Okay, so I could go maybe 190 here. And then I can go, since that's 50, I go by fives. I wouldn't want to go by ones. They're definitely not a good scale there. So let's go by fives. I only need 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then if I'm going, this would be 150, 160, 170, 180. So now all I have to do is take the points and I would put them right on there. So, for example, the first one that I have is 29.2 and 167. So I would go to 29. Right, there's 30, 31, there's 30, 29, and then I'm going to go up to 167. So that would be right about there. Okay, and then I would do 27, which is about 28, and 172. So there's 28. And there's 172, so I'm starting to get this. And I could just keep going. Actually, I have a 33, so I'm going to go one notch afterwards. And a 180, so that'd be right about there. Okay? And I would just continue to make this graph all right, till I get the whole screen filled up. I'm not going to do that because I already have it typed in, 29 and 167. So it's going to look something like that. So then here, let's go back to this so you can see this. What I'm going to do is I'm just going to go to this little graph setting tool, all right, and put in my own window. So on the x-axis here, and I'll have this all set up for you for when you want to do it. Our x-axis, our minimum is at -10, but we already said by hand I was going to do 20, so I'd put 20 in there, and then I'm going to put like maybe 35. Okay, the step would be how much you're going to go by, and we went by 1, so I'll put 1 there. And then for the y-axis, I said 140, and then for the y here, I said 190. And then I think I said I was going to go by 5s. Okay, so now you can see there's the graph right there. All right, with the dots. Man, that's nice. Okay. So, no, it is. I mean, you probably don't understand. I think it's really nice. Because I see that, I know where we're going with it, and it's going to be perfect. So, here's our little, this is our, you can see there's an obvious trend to this, okay, which is what you would expect, that as the foot length increases, the height's also going to increase, okay? So that's a nice looking, that's a pretty good looking scatter plot. And that's what scatter plots look like, okay? They're not connected. The dots aren't connected. They're just placed in where they're supposed to be at. Which is why you don't really need to worry too much about plotting these things and using fractions when you can use something like this. You can use Excel to make plots. You know, whatever you have, there's a lot of stuff available to make a graph if you need to do so. Okay. So again, I want to save this, and we'll come back to this then a little bit later on. All right, so let's go back to this guy here. Okay. So now that we kind of know a nice little information about graphing, what we're going to do is take a look at some linear equations. And this is really what we want to start talking about. Okay? So what a linear equation, what does that exactly mean? Well, first of all, they come in 3 different ways. They look like this. They look like this. Or they can look like this. All right? And so each one of these forms, all right, this one is called what we call a slope-intercept form. And we'll actually do this one later, but not today. And it might not mean much, but that's okay. Okay? This is what is called a standard form. Okay? And this is called a point slope form. All right? So the ones that we're really going to concentrate on are going to be these ones here. Okay, those are the ones we're going to really want to take a look at. Not so much tonight, but those are the ones we're going to take a look at. Okay, not so much the point slope form. It just doesn't get used very often. So we're going to, again, we're just going to look at this standard form because that's the one that's kind of in here the most. And what we're going to do is start off with this, and we're going to find some solutions to it. All right. So how do you do that? Well, you do what is called a T or an XY chart, like this. Okay? And this may seem pretty simple, but by the time we get done with a little bit of this, it's amazing how people kind of get confused with this. I'm going to write it out. You don't have to write it out when you do your stuff, though. Okay? Basically, we're going to graph lines. That's why these are called linear equations. So you only need a couple of points to get a line. The book has you do 5 points. You know, I say if you get 3 points, you're probably going to be okay. You need 2 points to get a line, and then the third one is a little reference. But we'll go ahead and start out and do 5 of them because that's what they have you do. All right. On the x part, you can pick any numbers you want. Obviously, 0 is the easiest one to pick. Okay, and then after that, what we're going to do is we're going to substitute those points in for our x and figure out what y is. Now, you might want to, before you go ahead and do that, is take this equation and solve it for y, because it might be easier. Right? So if we're going to solve this equation for y, what we want to do is move this x. Okay, so I'm going to come down here. I'm going to go 2x plus y equals 10. I'm going to solve this just like I would a normal equation that we did before in chapter 2. And I'm going to end up with something that looks like that. Okay, so all I did was move this x over. Okay, I'm solving for y. I move the x. That's kind of what we want to do.
Can we solve it for the x?
No, not in this case. You don't want to. You know, actually in math60222 you will bounce back and forth like that. But right now we want to solve it for y. Okay, because we already know the x's. All right, so now what we're going to do, and again, I'm going to write this all out, but you surely don't have to. I'm going to go 10 times 2 times 0 like that. Okay, and this, of course, is going to give me 10 because 2 times 0 is 0. 10 minus 0 just gives me 10. Then I'm going to take 2 here, put a 1 in there. 2 times 1 is 2 minus 10 is going to give me 8. Okay, 10 minus 2 times 2. 2 times 2 is 4. 10 minus 4 is going to give me 6. All right, and again, I'm writing all these out. You know, you wouldn't have to when you're doing your problems. You can just go ahead and look at it and get it if you can. This is going to be a 4. And our last one would be 2. Okay, so the solutions to this would be 0, 10, okay, 1 and 8, and 2 and 6, and 3 and 4, and 4 and 2. So those are some solutions to it. How many are there? 5? How many total solutions do you think there are? Uh-oh. Well, let's take a look at it. Many is correct. So if I was to graph this thing on a, just go ahead and graph it. Okay, 0, 10 would be my first number. So 0, 10, I'm going to have to move this graph down, so I'm not going to have enough room here to do this. Okay, so I'd have to make maybe like this. 0, 10. Okay, there we go. 1 and 8. 2 and 6. 3 and 4. 4 and 2. Now this is not a scatter plot, this is actually an equation, so I'm going to draw a line through it like that, kind of anyway, a little shaky there, but that's a line. So now let's re-answer the question, how many solutions are to this? How many points on that line? A lot. Infinite, right? Okay, there are a ton of points. So this is just 5 solutions, but there's infinite number of solutions on there, because this line extends downward forever, okay, in either direction, or it goes upward, downward, however you want to think of it. Okay, we usually call this a line that has a negative, it's going down, all right, because from left to right, it's going down, okay. So it has many solutions. You just found 5 of them, okay. You could have picked any x's. We could have picked 20, 21, 22, 23. We could have got numbers, but we didn't. We picked those ones that were the easiest ones to pick, all right. So let's do another one, same idea. This time let's go with a negative 3x plus y equals negative 12. Okay, might be easier to solve this for y. Well, if we solve for y, what are we going to move? What do we got to get rid of? Yeah, we got to get rid of that 3x, right? How are we going to do that? Yep, we're going to add it to this side, add it to this side, okay? All right, so now that I have that, okay, I'm ready to go ahead. Just pick some numbers for x. Again, the book's going to have you pick 5 of them. Okay, I always like to start with 0. 0 is a good choice. Positive or negatives, they'll have you probably start with some negatives. It really doesn't matter, okay, whether you do negatives or positive. In this case, it doesn't. So again, I'm just going to write this out. I wouldn't expect you to, but there's going to be 12, 3 times 0 there. Negative 12 plus 3 times 1 here. Negative 12 plus 3 times 2 here. Negative 12 plus 3 times 3. Negative 12 plus 3 times 4. Okay, so let's see. We're going to get a negative 12, negative 9, negative 6, yep, thanks. Negative 3, and 0. Okay. So all I did was pick, you can pick any numbers you want for x, okay? So when you come up to a test question or a quiz question, it says, you know, find 5 solutions, or find it, you know, fill in a chart or do a graph by charting, making a t-chart or an xy chart. This is how you would do it. All right, you just come up with a graph. Here we go. Notice I'm not even putting any dashes on here. I will this time, but I didn't last time because I just kind of estimated it. If we wanted an accurate sketch, then I would use something like what I have on the computer, a Desmos or a graphing calculator or something like that. We're just sketching these things, you know. And I've seen people, you know, get their rulers out, make sure everything's right. You don't have to go to all that work because it's just not needed. Here's a situation where we have a negative 12 and I only have 4. All right, I can go by 3s here to make it a little bit easier. So what I'm going to do is I'm going to say to this, you know, to whoever it is, me probably in this case, I'm going to go by 3s. Okay. Now, if I go by 3s on the y, but go by a different scale on the x, it doesn't change your graph as far as what it is, but it will change the accuracy of it as far as what it looks like. Okay. And I can give you an idea of what that is. So I'm going to go by 3s. Well, let's see. If we go by 3, that won't be good. So we'll just have to go by 1s here. Okay, so let's see. We got 0, negative 12, so that'd be right there. And then 1, negative 9, so that's going to be right there. And 2, negative 6, so that's right there. 3, negative 3, that's right there. And 4, 0 is right there. So there's a line. This time I'm going to cheat a little bit. Here we go. Maybe I'm going to cheat. Thought I was going to cheat, but I guess not. Okay, so there it is. There's what the line looks like. Okay. So I take this guy, solve for y. You don't have to, but it's easier. Solve for y, pick some numbers, figure out what they are, make a graph. That's probably exactly what it's going to be asking you to do. I'm going to double check here. I'm pretty sure that's all it's going to ask you to do. Okay. Let's try. So here's some that are a little bit simpler. Let's try y equals 3x minus 4. So now we have one. We don't even have to solve it for y. It's already solved for us. Okay, I'm going to make my little xy chart. Again, this time I think I'll start at negative 1. Just for kicks this time, maybe I'll just do 4 of them because I think we're getting the idea. 3 times negative 1 minus 4. 3 times 0 minus 4. 3 times 1 minus 4. See, I'm just putting those numbers in there. Okay, that's all we're doing. So 3 times negative 1 minus 4 gives negative 7, right? 3 times 0, what's that going to give us? Negative 4. 3 times 1 is 3 minus 4. Negative 1. 3 times 2 is 6 minus 4. 2. Okay, there. So that's how I find the solutions, right? So now what I'm going to do is make my little graph. It might ask you to do that. Let's see. I'm checking to see. No, I don't think it's asking. Oh, yeah, it does. I see some problems there. It asks us to do that. So we'll graph it. I want to shrink this down a little bit. Let's see. We have negative 1. Yeah, I can put these ones on here, I guess. If you have graph paper, it's kind of nice, but then you don't have to, like I said. -1, -7, so that's way down here someplace. 0, -4 be right about there. 1, -1 would be right there. And 2, 2 is going to be right about there. So there's my line. It's going to kind of look like that. Okay. Again, if I wanted to graph it real accurately, I'd use some sort of a software package or something that would do that. Okay, I'm not interested in getting good straight lines at this point. Just want to make sketches. Okay, just want to make sketches. Oh, what if we had one like, what if we had one that just said y equals 3? Okay? All right, so we'll make some, oops, I got excited there for a second. Here we go. X, y. I'll pick some numbers for x again. I'm going to go all the way here to -1, 1, 2, 3. Well, if I put -1 in this equation for x, what am I going to get? Is there an x? No. What does it say?
3.
Y equals 3, so I guess I'll get 3. What am I going to get when I put 0 in there for x? Don't have an x, so I get 3. What do you think this one's going to be?
All the same thing.
They're all going to be the same, aren't they? Okay, so if I come down here and graph this line, all right, it really doesn't matter what I have for x. Every single one of them is just going to be 3. So I'm going to get this nice horizontal line here at y equals 3. Okay, horizontal line. All right. Yeah, I think oh, let me do this for you. Actually, let's take a look at this. Let's go to on page 229. Okay, let's see what's after that. 43. All right, cool. So let's take a look at 41, y equals 2x plus 6. Question is, determine whether each ordered pair is a solution or not. Okay, so I start out with this. That's my equation. It gives me some points. 0, 6, -3, 0, and 2, -2. So what I'm going to do is start to figure out, whether these are solutions or not. How do I do that? Well, I'm going to put 0 in for x and see what I get. 2 times 0. 2 times 0 is 0 plus 6 is 6. Yeah, that's a solution. That one works because 0, 6 worked. So now I'm going to check this other one out. 2 times -3 plus 6, y equals 2 times -3 plus 6, 0. Good deal. So that one works too. Okay, y equals 2 times 2 plus 6. 2 times 2 is plus 6. Y equals 10. Uh-oh. 2, -2. So that one's definitely not a solution. All right, so when it's asking you whether they're solutions or not, you're just going to take the x point, put them in, see if you get the y. Okay, that's how you tell. All right. So, any questions on anything we just covered there on 3.1? Nothing. Nothing. Good. Hey, let's do this. Let's take a like a 10-minute little break here, and then we'll do 3.2. So. Okay, So what we're going to talk about now in section 3.2 is graphing equations using something called x and y intercepts. All right. So this is actually pretty straightforward to do. There's a little trick to it. All right, the way you can do it. First of all, I'm just going to hit this, put this little equation like here. Okay. We're going to find the x and y intercepts, but first of all, we want to know, well, what exactly are the x and y intercepts? I'm toggling back and forth here. To put this in the equation, I'm going to solve this for y real quick. Okay, so that's what this would look like. I'm going to get back to a normal graph for us. Okay, so that's what this line looks like if I graph it. The x and y intercepts are exactly where it crosses the x and y axis. So if I go to this point here and click on that, it says 0 and 4. That is the y-intercept. If I go down here, 6 and 0, that would be the x-intercept. All right. To find that, obviously it was pretty simple to just graph it on this nice little app here, but we can also do it pretty simply by looking at the equation. So we're going to pop back to this. Looking back at this equation right here. Come on. There it is. All right. If you notice that when the x-intercept, y was 0. So at the x-intercept, the y-coordinate has to be 0 because that's where it crosses that axis. Same thing with the y-intercept. The x has to be 0. Okay? So we can find these things by simply putting 0 in to one of these equations. So if I want to find the x-intercept here, I'll put 0 where y is. All right, so I'm going to have 2x plus 3 times, again, I'm going to write all this out, times 3 times 0 equals 12. This is, of course, going to be just 2x equals 12, and x will be 6, and that's exactly what we got, right? Okay? Same thing here. Now what I'm going to do is I'm going to take and I'm going to put 0 here where the x is. So I have 2 times 0 plus 3y. That's not a very good 3. Plus 3y. Okay, is equal to 12. And this is just going to give me y equals 4. And that's where it was, right? Okay, there's my x and y intercepts. All right, that's all we did there. Now, to do this, okay, and the way I always tell people to do it is, here's my equation. All right, it's kind of hard for me to demonstrate. I think I'll demonstrate it up here and show you. It'd be easier. So if I have 2x plus 3y equals 12, and I want to know what the x-intercept is, okay, what I'm going to do is cover up the y with my hand like that. 2x is equal to 12, so what does x equal? 6. If I want to find the y-intercept, I cover up the x. 3y is equal to 12, so y is equal to 4. Okay? All I'm doing is just covering them up because essentially the x and y's are 0 at those points. So I don't have to worry about it. I can just use my hand to cover them up and get the answer. What's that? And what the book has you do is it has you using the x and y intercepts to make a graph. Okay. To be honest with you, the x-intercept's not very important when it comes to linear equations. It's very important with equations that have a little higher up than linear equations. Okay. So if I want to graph this, here's how I'm going to graph it. Okay, so the x-intercept is going to be 6. I'm going to put 1, 2, 3, 4, 5, 6. right there. Y-intercept is 4. Put that point, and there's my graph right there. All right, just exactly as it showed up here on the screen. Okay. So in this case, you don't have to make a chart. You don't have to come up with a bunch of points and connect them. It's just the x and y intercepts. Connect them with the graph them on the axis, and then just draw a line. Okay. So we'll try another one here. So let's go with negative 2x plus 4y equals negative 12, like that. So there's my new one. Again, I'm going to find the x and y intercepts. Okay, x and y intercepts. So to do that, all I basically have to do is just cover it up, right? So if I come up here, okay, and I go negative 2x plus 4y equals negative 12. I cover up the x, that's going to tell me the y. What would y be?
Negative 3.
Negative 3. If I want to find the x, I cover up the y. What is x going to be? 6. Yeah. Just using the cover up method, and that works like a champ. Okay, there's my x and y intercepts. Let's see, my x intercept is 6. Y intercept is negative 3. So now I'm going to go ahead and make my graph. One, 2, 3, 4, 5, 6. There's that one. Negative 3. Connect them with a line. Kind of missed that one a little bit there. There we go. All right. There it is. Okay, that's how you find the x and y intercepts. All right. All you can put 0 in there if you want to, but really all you got to do is just cover things up. Okay, all you really got to do. On your assignment, it's going to ask you to make a checkpoint. You don't have to make a checkpoint. 2 points should be good enough for us to get it. Let's try another one. Plus 5y. What if it's going to turn out to be something that doesn't have a going to give you a fraction maybe, so we'll have something like this. Okay, we want to find the x and y intercepts. Okay, so if I want to find the x intercept, I'm going to cover that up. So I'm going to cover up this 4 to find, to find the y-intercept. I'll cover up the 4. Okay, so then what's my y-intercept going to be? 3. If I want to find the x-intercept, I'm going to cover up the y, so I can't see that. What would that be? Yeah, so it would be 15 over 4, okay, or 3.75. All right, so then now I'm going to graph that. It's negative. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, so I'm going to go, let's see, 3 for the y. 3.75. Here's again. Now I got to guess about where that is, so I'm not going to, get too excited about it. Just going to kind of estimate it. Oh, negative. Thank you. Thank you. Thank you. Thank you. So I'm going to go negative back this way, and there it is. Okay. So that's kind of slick. All right. If we have one, say it's y minus 3x equals a 0, okay, so then you go, okay, I'm still going to find the x and the y-intercept. Here's the x-intercept. Here's the y-intercept. Okay, x-intercept I'm going to cover up. The y part? So what is x going to be then? In order to make that work, we cover up the y. Negative 3x would be equal to 0. So what does x got to be? Uh-oh. If we have negative 3x equal to 0, what does x got to be? What times 3 is going to give you 0? 0. Oh, it's just 0. Okay. Y-intercept. Let's see. We'll cover up the x. I'm going to cover the negative 2. So that's going to be y equals 0. Okay. So 0, 0. Now we're in trouble because my x and y axis here, my x and y intercepts are 0 and 0. I don't have another point to go with. So what I would have to do is pick another point, okay, that would work on there. So this one I actually do have to make kind of a reference point. I'll just go like this with what I was doing before. Okay, so I make a little chart even though I'm only going to pick one number. Maybe I'll pick 2. So I'll put 2 in. So I get y equals 3 times 2 equals 0. Y minus 6 equals 0. What is y going to have to be in order for me to get that 0 there? 6. 2 and 6 is up here someplace. There it is. Okay. So in that case, the x and y intercept was the same point. That's okay. That's a possibility that could happen. All right. That could happen. The other thing I noticed they have quite a bit of in this part here. I'm going to drop back to this guy. Go back into here. I'm going to get rid of this. We've already kind of did this. If I have y equals 5, okay, notice that all I have there is just a nice horizontal line at, guess what number? 0, and where's it at on the y-axis? 5. Okay, just y equals 5 is where it's going to be. Okay. If I go x equals 3, this time I have a vertical line. Hopefully you can see it's kind of in a green. Let's see if I can change the color here. Thought I could. There's probably a way. I'm being dumb. I don't know. So I'm trying to make it a little bit darker for you. But that's where that one is. It's at x equals 3. So that would be a vertical line. So if we go y equals negative 2, where's that going to be? What kind of a line? Vertical or horizontal? Horizontal, where at? Negative 2. Okay, right there at negative 2. Okay? Alright. These are all just horizontal vertical lines. X equals negative 6. Right there. Vertical line at negative 6. So all these lines are just telling you where they are. They're either going to be horizontal or they're going to be vertical. Okay? And they're going to, so there's going to be some where they're going to have you graph them. There's going to be some where they're going to have you just write equations for them. Okay? In the book. Alright? Any questions on those ones? Vertical and horizontal lines. Horizontal. It's going to be like a y equals whatever the number is. Okay? Vertical. Okay, x equals whatever the number is. Alright. Okay, so what I'm going to do then is do like we have been doing. I'll give you some here to work on and we'll go over it. And those you want to participate in that, I guess you can. 228. Do some of these just to practice and make sure you know what you're doing before you take off. Yeah. Yeah. That's all I got. Let's see. So, Christine asked a good question about 9 through 24 on page 228 as far as, do you need all separate graphs for those? You can put them all in one if you want. Okay. I don't have the thing.
What thing?
I thought I uploaded it, but I didn't.
That's cool, man. You can
kid tomorrow, but yeah. See you later. That hurt my feelings. No, it hurt my feelings.